All right, so here's why we're going to need this log rule, this log function, is that we are going to solve equations using logs. And every time you've solved an equation up to this point in math, you never had to solve for the exponent, right? That's, again, the exponential equation part of things. You've had to solve for different things, but never the exponent. And so the log rules are going to allow us to solve for an exponent. And so in this case, I've got 4x is equal to 320, and I want to solve for x. And so here's what I'm going to do. I am going to take the log of both sides. There we go. So I've just taken the log of both sides. Now the log of 320, that's a number. Again, the log function, you put in the number, it becomes smaller, whatever it is. And so because the log function takes it to a base of 10, what would this number be if I had a power with a base of 10? What would the exponent be? That's essentially what it's saying here. And in this case, if I type it into my calculator, I get log 320, I get 2.51. There we go. Now, over here, again, the big issue with solving for x is it's an exponent. But I'm going to use that log rule that I showed you there, where the log of a to the power of b is equal to, bring the exponent down, b times the log of a. All right, so I'm going to now do that with this. So I'm going to bring my x down in front, and so that I have x times the log of 4. What that has allowed me to do is it's allowed me to take that x that was an exponent, bring it down now to a normal number. So now it's something we're used to working with. All right, now I have x times the log of 4. But again, the log of 4 is a number. Now it's probably going to be a very small number because, again, the log function takes a big number and makes it a lot smaller. So if I take the log of 4 and I put that into my calculator, I get 0.6. Now this is just an equation that we're used to working with. All right, I just want to solve for x. X times 0.6, or 0.6 times x equals 2.51. Well, as we've done before, or you would always do in math, I divide by my numerical coefficient. And I get my x value to be 4.18. And there we go. So we are able to solve for an exponent using the log function, because the log function allows us to use that log rule to make the log, or to make the exponent a normal number. All right, let's try another one of those. So this time I've got 7x is equal to 1200. All right, but again, my first step here is I'm going to take the log of both sides. So I take the log of 7 to the power of x, and I'm going to take the log of 1200. All right, so again, the log rule here, the whole point of me taking the log of 7 to the power of x is I'm going to now bring this x down in front, so it's a normal number, it's not an exponent anymore, times the log of 7. Because again, I'm using my log rule here. All right, now the log of 1200, again, I can type that into my calculator. You get log 1200, and I get 3.08. All right, and again, I can simplify further here because, again, the log of 7 is a number. Probably not going to be a big one, but it will be one. So I'm guessing it's a decimal, and it is 0.85. All right, and then so once again, I want to get x by itself, so I'm just going to divide by my numerical coefficient here, which is the 0.85. And what I do to one side, I do to the other. All right, and then so my x value is equal to 3.62. Any questions about that so far? A little bit different, something you've never seen before. No doubt about that. All right, try a couple other ones here, a little bit harder. All right, so the next one here, let's see here. I got, I think this is my fourth example or something in here. So I got 3 to the power of x minus 2, right, is equal to 1350. All right, so again, this is similar to what we just had, but there's a little more going on with the exponent. No big deal, it's going to take us an extra step or two. All right, but again, my first step is still trying to solve for that exponent. I'm going to take the log of both sides. So I got the log of 3 to the power of x minus 2 is equal to the log of 1350. All right, now again, I'm going to use that log rule. So I'm going to bring this exponent, which isn't just an x this time, it's an x minus 2. So I'm going to put an x minus 2 in brackets because I'm going to be multiplying that log of 3, right? My exponent times the log of the base. The log of 1350, again, that is a, I can figure that out. That's a number. And so let's see, I bet you it's, let's see here, 3.13. All right, and once again, I can solve for log 3 here. It's going to be a small number, and that number is in fact going to be basically 0.48. All right, now there's a couple ways to do this one. To go from here, we can get rid of this 0.48 because it's multiplying this x minus 2 in brackets. That's one way to do it. Let's see, let's go with that. So we'll divide by the 0.48. What I do to one side, I got to do the other. All right, so those 0.48s are gone. Now over on this side, I have an x minus 2 equals, I take my 3.13, I divide it by 0.48, and I get 6.56. All right, and then the final step, again, I just said it was because the exponent's a little more involved, we got a couple extra steps. I'm going to move the minus 2 over to the other side. And so, of course, it becomes a plus 2. Well, 6.56 plus 2, our x value is going to be 8.56. And that's what our exponent would be. Or sorry, our x value would be. Looks like our exponent would be 6.56. All right, and the best part about these questions, you can always put it in your calculator and check it out, see if you get the right answer. All right, one more of those. Short lesson this morning. I have 4 to the power of x minus 5 is equal to 200 to the power of x plus 1. There we go. Now we have double exponents to solve for here. But again, because I'm solving for exponents, I'm going to take the log of both sides. So I got the log of 4 to the x minus 5 is equal to the log of 200. Yeah, the markers are rare today. Of x plus 1. There we go. All right, and again, I'm going to use my log rule twice on both sides. All right, so I'm going to bring the exponent down. So here I have a x minus 5 times the log of 4. And over here I have my x plus 1 times the log of 200. All right, so the log of 4 and the log of 200 are both numbers, so I can figure those out. All right, so I have x minus 5 times that log of 4. The log of 4, we already had that one. It's 0.6. Just put that in brackets. All right, then I've got the x plus 1 times the log of 200, which is at 2.3. All right, so now I got some solving to do here. I want to solve for x. So here's what I'm going to do. I'm going to do the rainbow rule. So I'm going to take my 0.6 and times it by x and take my 0.6 and times it by negative 5. Well, 0.6 times x is 0.6x. And then 0.6 times negative 5. I believe that's a negative 3. It is negative 3. All right, over to the other side, same thing. I'm going to do the rainbow rule. I'm going to take 2.3 and times it by x, and then 2.3 times it by 1, positive 1. All right, so I get 2.3 times x and 2.3 times 1. Well, that is 2.3. And now we just have an equation that hopefully should be able to solve, where I get all my numbers to one side and all my letters to the other. So I guess I'll move, let's see here. Let's get all my numbers over this way. So I'll move my 2.3 over here and yet my 0.6 over there. So all my letters are going to be on the right and all my numbers are on the left. So I have a minus 3 there. I bring the 2.3 over, it's a minus 2.3. Over on the other side, I have a 2.3x. This 0.6x is coming over, so it's a minus 0.6x. All right, well, I lose 3, I lose 2.3, I lost 5.3. And let's see, 2.3x minus 0.6x, it's like $2.30 minus 60 cents. I'm going to have 1.7x then. All right, looks like our x value is going to be negative. All right, so now the last step, I divide by my numerical coefficient, 1.7. Almost running out of room here. And my x value is equal to negative 3.12. And there we go. So again, the log function is very important for us because what we're looking at doing is we're dealing with exponential equations, which have exponents, and we're going to be solving for exponents. Solving when we get later on today, or shortly today, we are going to be looking at different situations, dealing with the formulas we had before, and solving for an exponent. All right. So again, that's the log function. A lot of students are happy with that because they get to learn that button on their calculator. There's some buttons on there you don't know about. Now you just got one extra one that you can figure out and use.